Hi, in this video we will do some examples for the values of higher derivatives of function at some points. Let us start with the first one. The function is square root of 3x minus 2 and we are supposed to find the third derivative and evaluate it at 1. Okay, to start, we have to find the first derivative. The first derivative, you see that this is basically 3x minus 2 to the power half prime. And well, this is the power rule. N u prime u to the power 1 less, and that gives us 3 over 2 3x minus 2 to the power negative half. You can go ahead and write this as square root 1 over square root, but since we are going to differentiate and find the other values, let's just keep it that way. And the second derivative we can find by, again, 3 over 2 3x minus 2 to the power negative half prime. Constant multiple rule and then a power rule. Negative half comes up front, derivative of 3x minus 2, and then 3x minus 2, negative half minus 1. And that gives us negative 3 over 4. Well, derivative of 3x minus 2 is 3, so let me write that one too. So it will be 9 in the numerator. And then 3x minus 2 to the power negative 3 over 2. How about the third derivative? Well, the third derivative is going to be negative 9 over 2 of 3x minus 2 to the power negative 3 over 2 prime. So negative 9 over 4 comes up there, and then power rule, negative 3 over 2 times 3x minus 2 prime, and then 3x minus 2 to the power negative 3 over 2, 1 less. That gives us what? This gives us, there's a 9 over 2 here, and then that will give us 81 over 8, and then 3x minus 2 to the power negative 5 over 2. So let me just make some space here. So this is the third derivative, since that's where we are going to evaluate our function at 1. So let's just simplify then this one. This is 81, 8 root of 3x minus 2 to the power half. And then f at 1 is going to be equal to 81 over 8 root of 3 times 1 minus 2 to the power 5. This is 81 over 8. 3 minus 2 is 1. 1 to the power 5 is 1. And then square root of 1 is just 1. So this will give us 81 over 8. That's what we have here. Let's do the second example. We definitely need more space here. Let me open it right now. Okay. First derivative, f prime of x. This is quotient rule, yes. X plus 1 over 3x plus 4 prime. And derivative of the numerator times the denominator minus the numerator itself times the derivative of the denominator, and then denominator to the power 2. what this gives us is 3x plus 4 minus 3x minus 6. And this cancels with that. The numerator is going to be negative 2. Denominator, however, is 3x plus 4 to the power 2. Okay, then the second derivative, if you want to find the second derivative here, you can go in two ways. You can either say, okay, this is a quotient, and we have to use quotient rule, but quotient rule will give you more complicated version of the derivative. Rather than taking the quotient rule, you can see that this guy is this, negative 2, and then you differentiate that way. So this way you have negative 2, the power rule applies here, prime 3x plus 4 to the power negative 2 minus 1. And what that does, that gives us, this is 12 3x plus 4 to the power negative 3. And continue going this way. You don't need to do the quotient rule here. Just power rule is what you get. So 12 negative 3 3x plus 4 to prime, and then 3x plus 4 to the power negative 4. That gives us 3 and another, so 12 times minus 9, and then 3x plus 4 to the power negative 4. And the fourth derivative is going to be 12 times negative 9. There's a negative 4 coming in, and then 3x plus 4 prime, 3x plus 4, 1 less. This will give us again another 12 times the negative sign will get that one. These two will be 12, negative 12, and then that number will be there. And then 3x plus 4 to the power negative 5. So this means that we have this number. It's a big number, but that is the numerator of this function. Now, evaluate it at negative 1. This will be 12. Well, 12 squared is not that bad number, but multiplying by 9 is what will make it not easy to grasp number. Okay, you can multiply, you get numbers there, but 4 minus 3 is 1. 1 to the power 5 is this. This is 144 times 9. Yeah. So the trick here was that if you would continue this thing here from the first derivative and go with the quotient rule, you will get very complicated terms. It would be awful. They needed to be simplified to be of this form. But considering it as a power and using power rule helped us a lot. Okay, so let's apply the last one. And this here again, the same trick will help us here. Rather than going with the quotient rule, you can do this thing. And this will give us negative 1 times x squared minus 3x prime, x squared minus 3x to the power negative 1 minus 1. This is negative 2x minus 3 x squared minus 3x to the power negative 2. Oh, this is bad. The writing was bad. Okay. Then the second derivative here is the derivative of this guy here. This is product rule, so this will be derivative of first one times second one plus the first one times the derivative of the second one. This gives us negative 2 times x squared minus 3x to the power negative 2. And then here we will get negative 2x minus 3. The derivative of this guy, negative 2 times x squared minus 3x prime, then x squared minus 3x to the power negative 3. Let's do a little bit more work here. So x2 minus 3x to the power negative 2. This derivative will be the same thing as there. So we will have plus 2x minus 3 to the power 2, and x squared minus 3x to the power negative 3. Let's just leave it that way, and then the second derivative at 2 will be negative 2 times 4 minus 6 to the power negative 2 plus 2 times 2 minus 3 squared, and 4 minus 6 to the power negative 3. And well, this is negative 2 over negative 2 to the power 2. So this is this guy. And here, this is 1 to the power 2, which is 1. And in the denominator, we have negative 2 to the power 3. This gives us negative 2 over 4 plus, minus, because minus 2 over 8. Very nice. This is a good number for negative 2 minus 1. That's what we get, negative 3 over 4. Well, just more examples of differentiating and seeing that putting better rules or different rules may give you different not simplified terms. So choose the ones that makes the differentiation easier. And that was the example.